All right, Mr. Berry here again with the same problem we've been dealing with for a little bit here, talking about this table that shows an amount of money, billions of dollars, spent on pollution control here in the mid to late 80s. What we've done in this problem so far is we've graphed the data with Desmos. We found a cubic regression model, and how we did this was we typed this into Desmos directly underneath there. We got to make sure that we use Y1 to represent what says up here. And we got to represent x1 with what represents over here when we type those in. We also figured out an r squared. The r squared value is a decimal value. It's going to be somewhere between 0 and 1. So when we convert it to a percentage, it's somewhere between 0 and 100%. And the closer we are to 100% is the closer the data represents this specific regression. And in this case, because the biggest exponent is 3, it's a cubic regression. And in this case, our R squared was 99.93%. So it's a pretty good representation of what's going on with this data so far. Now I want to take a look at writing out the cubic regression model, where I can find out that information, as well as maybe make a prediction, which is where we really want to end up with all of this. So the fortunate thing is that typing in the cubic regression here gives me a lot of information underneath, gives me the R squared. It also gives me some parameters. So I can go ahead and type those out in the specific spots. So for instance, A would be 0.15. I can't actually type that into Desmos, so don't try to kind of copy and paste it. All right, what you're going to have to do here is just go ahead and start something else. Now, maybe you're writing this out on a piece of paper. I'm going to try my best just to type it out here, so hang with me if you could. So we got y is equal to, my A value is 0.15. If you have Google extensions, I really like the Google extension of Equatio. We have x to the third power here. And it is time consuming, no doubt about it, especially once we get to some of these other ones here. Our B value, negative 1.55952. Negative 1.55952. Of course, we got the x squared on the back end of that. I might be able to type this into Equatio just like this. I'm not, but that's okay. I'll just push the back button and get 2 in there. Our linear term, 8.89286. 8.89296. I forget. 286. That was close. And of course, that's our linear term, and then we'll wrap it up here with our D value, 61.7024. 61.7024. And I'll go ahead and hit the enter button here and insert that. And that might seem ridiculous. Those decimal values are crazy. But what that does is give me a very accurate model to display this data right here. And I can use that moving forward, whether it be a business or in this case, some department for the United States government when it comes to projecting how much money we're going to spend for pollution control. The other thing I can do with this is go ahead and use the model to predict. So 1983 is year 0, which means 1990 would be year 7. We want to go ahead and figure out what would be going on in year 7, which is 1990, which is obviously what the question's asking for. And just like we've done before, I'll go over here. 7 is at the bottom. You can kind of see it outlined, and I'll go ahead and just click on my model to the best of my ability. See if I can get it over one little there. Keep on wiggling. 98.6. So we're almost at 99, which translates here to $99 billion spent on pollution control. Sounds kind of crazy. But again, using this cubic regression model, actually being able to type it out, even though it's kind of crazy decimals there, and then being able to predict the future to kind of help the calls and be able to get ready for that future.